For Algebra 2, Section 2.2, we're talking about linear equations. So basically, we're talking about equations of a line. The term linear means line. So we're going to learn all there is about lines, equations of lines, and different ways to deal with lines. Now there's three basic things you need to keep in mind. The first one is a linear equation. Anything that makes a linear equation, you're either adding, subtracting, or multiplying. Those are your only options of a variable. And again, variable is x, y, anything like that. But you should not be dividing. There should be no powers or anything like that. A line has no power of 2. It has no division. So something like this, 5x minus 3y equals 7, when it means a linear equation, it means if I graph this, it would look like a line, hence the term linear. This, if I graph this, it would definitely not be a line because of this divided by a divided x. Okay, so this is no. Okay, and this is yes, 5x minus 3y equals 7. Even though it's not the same formatting like you're used to, it is in fact a line. That means if I graphed it in my two charts that you learned last section, then I would get a line. A linear function is, this is the equation of a line, y equals mx plus b. M would be your slope, and we're going to learn more about that. But instead of a y, because of the term function, we're using f of x. Now remember, y and f of x are interchangeable. You can change them anyway. So the equation then becomes f of x equals mx plus b. So an example would be f of x equals 5x minus 10. Standard form looks more like this. The x comes first, then the y, and then the c, the one without a variable on the other side. A is the number in front of x. It's not the number including x, the number in front of x. And b is the number in front of y. So an example, if I took this equation and I put it back into normal terms, so y equals 5x minus 10. Sorry, this is a y. It's telling, and I rearrange it, so I took the 5x and I put it the other side. Remember, as long as I do what I do on one side, I do on the other, I can change the equation around any way I like. But the key is, what I do to one side, I have to do to the other. So here, I subtract 5x from both sides. I get negative 5x plus y equals negative 10. So my a is negative 5. My b, since there's no number in front of y, it's going to be 1. And then my c is a number without a variable, and that's negative 10. Sometimes, yeah, never mind. Just go ahead and write this down. Make sure you do your vocabulary, but write this down unless you've already written it down. And we're going to move on to our examples. Our first example is to write these two into standard equation. Now that's the one where x comes first, so ax plus by equals c. So right now in this form, it's in the, which form is in the linear function form, so we're going to rearrange it. So I need x on the other side. What I do to one side, I have to do the other. In this case, if I want to move the x to the other side, I have to do the opposite. Since this is a positive 3x, I'm going to subtract 3x from both sides. So what I end up with is minus 3x. This is a positive y, so plus y equals negative 9. Okay? So my a is negative 3. My b is the number in front of y, which is 1. And my c is 9. Sorry, negative 9. Next is a little bit more complicated because I have this fraction. And because the variable is on top and not on bottom, this is in fact a linear equation. I'm going to go ahead and get rid of this 3. And this is how I'm going to do it. What I do to one side, I have to do the other. So I'm going to multiply this whole thing by 3. This and this cancels out. That means I have to multiply this whole thing by 3. So what I get is if this cancels out, I end up with a 2x. On one side. Does that make sense? The 3 canceled out and I end up with a negative 2x. On this side, I end up with 2y minus 1. So what do I need to do here? I need to distribute that 3. So I end up with negative 2x equals the 3 times 2, which gives me 6y, and then the 3 times negative 1, which is minus 3. Okay? And now that there's no parentheses, there's no multiplication, fractions, I can go ahead and rearrange it. I have the x on the right side, but I don't have the 6y. So how do I get it on the other side? I'm going to subtract 6y from both sides. So what I'm going to get, or down here, is negative 2x minus 6y and negative 3. So my a in this fact is negative 2. My b is the number in front of the y, is negative 6, and my c is the one without a letter, which is negative 3. So here are my answers. Okay? The book doesn't like that the x is negative, so they try to make a positive, but don't worry about it. When I grade it, just make sure that you keep that in mind. So, but at least the numbers are correct. Oh, before you move on, hopefully you've already written this down, you need to do page 68, number 6. So go ahead and go to your book, page 68, number 6. Our final example is to find the x-intercept and y-intercept. And basically the main thing you need to know is to find any intercept. I hope I spell that right. I need to plug 0 in the other, in the other variable. Okay, so in order for me to find the intercept, I need to plug the 0 in the other interval. For example, this is y-intercept, so we're trying to find the y-intercept. Okay, so that means I need to plug in 0 the other variable. So if this is y, that means the other variable is x. So here's my equation. Okay, and I'm going to apply 0. I do plus y minus 4. So now I have how many variables? 1. Now you can only solve an equation when there's one variable. Okay, if there's more than one, then you have to do something to either get rid of it or substitute it, but you can only solve it with 1. So I couldn't solve it yet with this, but I could solve it now that I don't have an x. So negative 2 times 0 is 0, plus y minus 4 equals 0. I'm going to add 4 to both sides. I end up with y equals 4. Now I'm going to find the x-intercept. Okay, so that means I do the other variables. So if I have an x here, then that means I'm going to put a 0 in for the y. So I have negative 2x plus y, which is 0, minus 4 equals 0. So I have negative 2x minus 4 equals 0. I'm going to add 4. So I'm going to go over here. So add 4 to both sides. I end up with negative 2x equals positive 4. Now I'm going to divide both sides by negative 2. These cancel out. I end up with x equals negative 2. So my y-intercept is 4 and my x-intercept is negative 2. Now the question is, some of you guys are trying to figure out what the intercept is, basically. Well, the definition of an intercept is where it crosses that axis. So this is the x-axis. This is the y. My y-intercept tells me where on the y, when the other one is 0, does the line cross. So it tells me it crosses at y. So basically this point, my x is 0, but my y is 4. So that's 1 point. And then here, since my x is negative 2, what did I put in for y? 0. So I have these 2 points right here. And with any line, as long as you have 2 points, you can go ahead and write, put a line through. If you have especially the 2 intercepts, you can go ahead and put a line through them, because they'll give you a good basis of where the line is. So my first one, it starts at 0, goes up 4. 1, 2, 3, 4. The next one, it goes negative 2, but it doesn't go anywhere right here. So this is where it crosses the x. This is where it crosses the y, and I just need to connect it. That's how I graph my line. In order to find the intercepts, I have to put 0 for the other variable. So 0, 4, and negative 2, 0. and I'll go ahead and graph it and put a line through it. So when I have the two intercepts, I don't need to do the table, the 3-column table that we did in the last section. I can just put 0 for x and then find that intercept, and 0 for y and find the intercept. So go ahead and try it on your own. Page 68, number 8. Page 68, number 8. Don't forget your vocabulary, and I will see you tomorrow.